Hello, here we are. We are moving into something called completing the square. Cover some topics here. Again, this lesson will be covered in detail. Live Zoom lesson on Tuesday, April 21st. And the lesson will begin at 1:30. And that, of course, is after our office hours, which start at 1 o'clock. Okay, first of all, we're going to talk about some quadratic equations. We were working with quadratics way back in March before we left. This is one form of a quadratic equation, and this is called standard form. You've seen this for a while. You start with the x squared, go to the x, have a constant at the end. Something that you haven't seen yet is another form, and it's called vertex form. And it looks like this. Now, you don't know what these things mean yet. I'll explain that later on, but I just wanted to tell you that there are multiple forms of a quadratic equation. Just like when we were doing lines. Remember when we were doing lines, we work with slope-intercept form, we work with point-slope form, and we work with something called standard form there as well. Of course, that was different than this standard form because that was talking about lines. Here, we're talking about quadratics. Okay? Now, if you look at number 1 here, you clearly see that this thing's written in vertex form. Okay? Now, when it's written in vertex form like that, if we wanted, this isn't something you're going to do often. If you want to change it to vertex, to standard form, you can. So that's in vertex form. Let's change it to standard form. So obviously, this squared means x minus 3 times itself. Don't worry about this 2 yet. Let's just, x times x is x squared, x times negative 3, negative 3 times x, negative 3, we're just doing our distribution. Let's go ahead and combine like terms, which are in the middle here. So we get x squared minus 6x plus 9. And here, the last step we're going to do, well, actually, maybe not quite the last, but we're going to distribute this 2. So we get 2x squared minus 12x plus 18. And then, of course, we have like terms here at the back. So we end up with y equals 2x squared. Whoops, there should be an x there. Minus 12x plus 28. Now, I want you to realize that these two equations are the same. Okay? This is the standard form version of that. That's the vertex form version, but they are the same thing. Okay? And we'll get into all of what all this stuff means later on. Today we're just kind of doing some basic stuff. I'm just showing you that there's multiple forms of quadratic equations. Now this, of course, is in standard form. Let's change it to vertex form. And that's what we're going to learn today. Now we're going to come back and do this a little bit later in this lesson. But this is what we're going to get into here today. Okay? Changing something from standard form to vertex form. All right, now to do that, we have to do a little refresher on our factoring. We spent a lot of time on factoring. I hope you guys remember. You know, here, if I was to factor this one, this would be x plus 3 times x plus 3. Remember, this got some disappearing ink today. Not too sure why. See, that's where it went. Hopefully it doesn't do that anymore. You know, this gives me 3x, that gives me 3x. Together, that's 6x. 3 times 3 is 9. We spent forever on this. I'm certainly hoping that you're comfortable with this. Okay? Now, this could also be written as x plus 3 squared because you have the same thing twice. Now, here, if you factor this, see what you're going to start to notice is, if you remember some of the shortcuts I gave you way back when, this is a perfect square. And when you have perfect squares on the end, you see the 9 is a perfect square too. When you have a perfect square on the end, it's usually best to try the square roots first. And they work here as well. Negative 5x and negative 5x gives you negative 10x. Negative 5 times negative 5 is positive 25. And you could write this as x minus 5 squared. What do you notice here? Perfect square again. You know, this is going to be x plus 7 times x plus 7, and of course x plus, these are all what we call perfect square trinomials. So I don't know if I'm going to go through all of them here. Even on this next row, remember 1's a perfect square. 1 times 1 is 1. These are all perfect square trinomials. So all of them, this is going to be x minus 2 times x minus 2, which you can write as x minus 2 squared. I'm hoping that this is all this factoring rings a bell. Okay, what we're going to be doing in our lesson today, when we get to the new stuff, is we're going to create one of these perfect square trinomials. But this is all old stuff. We've done this before. You know, this is going to be x plus 1, 2 of them. This is going to be x minus 4, 2 of them. This is going to be x plus 9. This is going to be x minus 8. This is going to be x plus 6 squared. Now remember, if everything's plus here, it's got to be plus down here. Because this one's minus, that's why that one's a minus. See, the negative, the negative. We spent a long time on this, so you should be comfortable with this factoring. But these are all called perfect square trinomials. Okay, now what we're going to do is we're going to do something called completing the square. Now here's the procedure. It says make sure that a is 1. Actually, I think a is going to be 1 in all of our problems, so it's not really anything that you're going to have to worry about because we're only going to be dealing, see how down here there's an invisible 1? We're not going to have to worry about this particular thing. Now, what our first step should be is, well, we'll get to that later. We can go straight to step 2. Okay, take a look at this one here. You see here, I'm going to talk through it. You can go back and look at the steps here in a second. What we want to do is we want to create a perfect square trinomial. So we're going to convert each equation from standard form to vertex form, but we're going to do that by completing the square. And this is brand new. All right? And you got to watch step by step here. If you follow what I'm doing, you're going to be fine. So we're going to take this equation and we're going to rewrite it. But before I write this last term, the constant, I'm going to leave a little space because we're going to put something into that space. Now, here's what's new now. So what we're going to do, we're going to take this, what we call the b term, the number that has the x with it, okay? We're going to cut it in half. Obviously, half of 6 is 3. And then we're going to take that number 3 and square it. 3 times 3 is positive 9. And we're going to write that positive 9 right here. Now remember, if I add 9 on the side of an equation, I got to keep my equation balanced. So I'm gonna keep it balanced by subtracting 9 right there. So really, 9 minus 9, that they cancel out. I'm just changing how it looks. But what I've done, you see, the whole purpose of doing what we just did, the cutting in half of this middle term and then squaring it, what that creates is a perfect square trinomial. See, if we factor this, that's going to be x plus 3 times x plus 3. And then these two things together, 2 minus 9 is just a -7 hanging off the back. Okay. Now we write our final answer. Remember, we have 2 of these. So we write x plus 3 squared minus 7. This is now in vertex form. Okay. Now the vertex of a parabola, I'm just doing a rough sketch of a parabola. Just to remind you, if I have a parabola, this point, the absolute bottom of it, or the absolute top, where it starts to shift, that's called the vertex. It's what we call one of the critical points of a parabola. And knowing the coordinates of that vertex is going to be very important. And we're going to do a lot more with that here going forward. Okay? The nice thing about vertex form, so we're actually done with this problem based on these instructions. But the reason why we do it is this vertex form, whatever value here for x that makes these parentheses come out to 0, obviously this would have to be -3. That would be the x value of our vertex. And then this number hanging off the back, that's the y value of our vertex. So we know the coordinates of our vertex by changing the equation into vertex form. That's one of the benefits of the vertex form is that you have that vertex at your fingertips. All right. Here's another one, same thing. So it's all the processes are the same now. On the back side, there'll be a couple that's a little different, but I'm going to rewrite this. I'm going to leave a little space before I write the -2. I'm going to cut this in half. I'm going to get -5. Now remember, when you square -5, a negative times a negative is still positive. So this is always going to be a positive number here. But if I add 25, I have to keep it balanced by subtracting 25. And this is going to factor to x minus 5 times x minus 5. And you get -27 hanging off the back. I usually don't show this step. I usually go straight to this. Y equals x minus 5 squared minus 27. But I just want to show you, where this is coming from. It's coming from this. Where does this come from? That's why we're cutting this in half and squaring it is we're creating something that's a perfect square trinomial that'll always give us something like this. Now, if we were asked for the vertex, we would say that the vertex was 5, -27. Okay? So, before I go to the last problems on the back, let's go all the way back to the first page. See, now we actually have the skills to do this problem. Maybe you want to try this one yourself here. And you can pause this and then listen to me here in a moment to check yourself. So I'm going to rewrite, leave a little space, cut this in half to -4, square it, keep it balanced. This gives me x minus 4 squared minus 2. That is my vertex form, which means the vertex of this thing would be for -2. Okay. All right, almost done here. This one's going fairly quickly. Okay, now this one here on the back side, number 3, looks a little bit different, right? You see that there's no y in this particular problem. We want to get all this stuff on one side. And again, move everything to the side where x squared is positive. So we want to move that over there. And we would have like x squared plus 4x. Of course, this would be a -7, right? Now, this 0, you know how we kind of interchange 0 and y sometimes when we're dealing with like x-intercepts, x-intercepts y is 0. We can change this back to a y. Now leave a little space. And now we're going to cut this in half, 2, square it, balance. And here I get x plus 2 squared minus 11. What's the vertex? -2, -11. So that's the only thing that's different. So this is kind of the new step 1, is you want to make sure that everything's on one side of the equation. Of course, we've done that many times before. You want to be equal to 0, and then you change that 0 to like a y. Okay, or f of x or g of x or whatever. We want everything on the side where x squared is positive, so we would move this over. So x squared minus 6x plus 6. This is y, x squared minus 6x. Leave a space. Cut this in half to -3. Square it. Balance. And we get x minus 3 squared minus 3. So my vertex is 3, -3. A lot of times you're going to be asked for that, so that's why I'm adding that into this to this worksheet, even though the instructions just said to convert to, this will come back, convert to standard form. Convert to vertex form, which we did. If you guys want to try this last one, you certainly may. You can pause this if you want. It's not different. Cutting in half, square it, keep it balanced. So we have a vertex of -2, because that makes that 0. There you go. Now again, I moved along somewhat quickly, but we're going to do a live lesson on Tuesday, April 21st. It'll be at 1:30. We can go nice and slow. You can ask questions and try to take care of whatever you got. Okay? Hope to see you then.